Now we'll go for the next problem. A rod of cross-sectional area of 20 mm by 20 mm and 1 meter long is subjected to a compressive load of 40 kilonewton. The modulus of elasticity of steel may be taken as 200 kilonewton per mm square. Find stress, strain and decrease in length of bar due to the applied load. So he says it's a cross-sectional area of 20 mm by 20 mm of 1 meter long. So we will take the bar of a rectangular cross section. So here, so this is a bar of 1 meter long. So we are going to consider it is a 1 meter long bar. So it will be 1000 mm. Having an axial compressive load. So we have a compressive load of 40 kilonewton. So since it is a compressive load, both the forces are acting towards each other. So here this will be P, which is equal to 40 kilonewton, and here this will be 40 kilonewton. And having a cross-sectional area of 20 mm by 20 mm, so that means it is a square bar. So here, so this will be a square bar of 20 mm by 20 mm. So we are going to consider this as a square bar, which is the square of 20, square of 20 mm. This is the square cross section. So we have to find out the stress, strain and decrease in length of the bar due to the applied load. So here, first we are going to write the data whatever it has been given. So the data part, we have cross-sectional area of bar, cross-sectional area of bar which is capital A, which is 20 mm by 20 mm, which is a square cross section. So again, so here it will be 400 mm square. So this will be 400 mm square. Then we have length of the bar, length of bar, which is given to be small l, which is 1 meter long, that is equal to 1 into 10 to the power of 3, which is equal to 1000 mm. Because all these units has to be converted into mm, because it is being given here, the modulus of elasticity is given in terms of mm, and also cross-sectional area is given in terms of mm, but only the length is given in terms of meter. So we have to change that meter into mm. So finally when you are substituting in the problem, so all the units should have the same unit. So that is our condition. So then only we will be able to solve the problem correctly. So now then the compressive load, applied compressive load, applied compressive load, applied compressive load, which is capital P, which will be equal to 40 kilonewton. So 40 kilonewton means it is 40 into 10, 1 kilo means 10 to the power of 3 newton. So then the modulus of elasticity of steel, modulus of elasticity, that is Young's modulus, modulus of elasticity E, elasticity comma E, which is given by 200 kilonewton per mm square. So 200 kilonewton per mm square. So that will be equal to 200 into 10 to the power of 3 Newton per mm square. 1 kilo means 10 to the power of 3. So that will be equal to 2 into 10 to the power of 5 Newton per mm square. Then what we need to find out is find stress. So we need to find out the value of stress. So which is to be found out. Then we need to find out the value of strain, which is epsilon. Then and also the decrease in length of the bar. So why do we need to find out the decrease in length of the bar? That is basically because since he has given the applied compressive load, since the load is under compression, the length is automatically it will going to reduces in length. So that is the reason why we need to find out it is the decrease in length. First, we will going to find out the stress one. So the solution is stress is given by sigma, which is applied compressive load divided by area of cross section of the bar. So which is the square bar. So that will be equal to applied compressive load is given to be 40 into 10 to the power of 3 divided by area of cross section of the bar is 400. So naturally it will going to be 100 Newton per mm square. 100 Newton per mm square. So here, so this will be equal to 100 Newton per mm square. So this will going to be the value of stress. Now, to find out the value of strain, that is epsilon, to find out the value of strain, which is epsilon, it will be equal to change in length by the original length. Change in length or decrease in length, we can say. Decrease in length by the original length. So decrease in length by original length. So decrease in length by original length. Decrease in length by original length. So that will be equal to delta L by L. Delta L by L. So this is the problem in which he says, so we need to find out the value of delta L also, and the length of the bar is known. The length of the bar is 1000 mm. But here the strain which we don't know, because the strain is also we need to be found out. So in this particular equation we cannot apply this condition now itself. That is basically because we have two unknowns. One unknown is strain and the other unknown is decrease in length. So we need to find out the strain. But we know the Young's modulus. Since we know the Young's modulus, so we know that Young's modulus E is given by which is stress by strain, so that will be equal to sigma by epsilon. So we know that Young's modulus is given to be 2 into 10 to the power of 5 equals the stress value is 100 by epsilon. Therefore, epsilon will be given by 100 by 2 into 10 to the power of 5. That will be equal to 5 into 10 to the power of minus 4. 5 into 10 to the power of minus 4. So this will going to be the value of strain. So once you get the value of strain, so we can apply the same problem. Now we can apply the value of this as strain, which is 5 into 10 to the power of minus 4. We know delta L, we don't know the delta L which you need to be found out, but we know the length of the bar, which is 1000. So now we need to calculate that. So to do that, so we have the strain. So we have the strain will be equal to strain, which is epsilon, is given by change in decrease in length by the original length. Decrease in length by the original length. So that will be equal to delta L by L. So what is strain? Strain is given by 5 into 10 to the power of minus 4. 5 into 10 to the power of minus 4, which is equal to change decreasing length is delta L by what is the length of the bar is 10 to the power of 3. Therefore decreasing length delta L will be equal to 5 into 10 to the power of minus 4 into 10 to the power of 3, which will be equal to 0.5 mm. So decrease in length of the rod, which will be equal to 0.5 mm. So this will going to be the final answer.